Welcome to our review on radioactive decay and half-life. So, we've already encountered this term activity, which refers to the number of decays per second. Now, what we actually find is that in a radioactive substance, then atoms are decaying all the time. So what we actually find is that as time passes, the activity of that sample is going to gradually decrease. When we refer to the half-life of a sample, what we're actually talking about is the length of time it takes for half of the radioactive nuclei to decay. So basically what we're looking at there is how long does it take for the activity to halve. As you can see in the little diagram at the bottom there, we're starting off with the little green ones representing our radioactive atoms, and what we've got there is 12 little green atoms in our first picture. After one half-life, there's down to 6 because obviously half of them have decayed, and then after a second half-life, we're down to 3 because again the number of radioactive atoms has halved. There are two things that they might ask you to do with the half-life of a sample. And the first one is using a graph to actually work out how long the half-life is. So the kind of graph you would see on your exam paper is on the left there, with the time along the bottom and the number of counts or the activity on the y-axis. Now what we need to do to work out the length of time for one half-life is obviously look at the maximum count first of all. In this case it's 80. So we know that the half-life means that half of those are going to have decayed, so that means we're going to be looking at 40 counts. So you come down to 40, draw a horizontal line across until we meet the curve, and then you draw the vertical line down to your x-axis and read off the number of time in days that it says. In this case, it's going to be 2 days. So that obviously gives us the half-life of 2 days for this sample. The second thing they might ask you to do with half-life is to actually use calculations to determine some information. So in the question, get some information along the lines of nitrogen 17 has a half-life of 4 seconds, a sample has an activity of 1000. Now they could ask you what the activity would be after a certain number of half-lives. So the example I've given you here is what would the activity be after 3 half-lives. So we start off with our 1000 activity, half of that is going to be 500, so that's 1 half-life, half that again is 250, 2 half-lives, and then 3 half-lives takes us down to 125. They may also ask you how long it takes for the activity to reach a certain number, in this case 125. Now we know, obviously by dividing it by 2 each time, that it takes 3 half-lives to get down to 125. And if we look back to the information that we had at the beginning, we see that half-life is 4 seconds. So in order to work out how long it takes for the activity to reach 125, all we do is 3 times by 4, which gives us 12 seconds.